Hello everyone, thank you for joining me today for this exciting Syncfusion webinar. Bring AI to your Blazor apps, build smart interactive maps with Azure OpenAI. I'm Shriram Sankaran, Senior Product Manager at Syncfusion. So whether you're building enterprise apps or just dipping your toes into .NET's AI-powered future, I'm thrilled you are here. So imagine this. You are a developer with zero geospatial expertise, but you need to create an interactive map that responds to natural language queries like hospitals in New York and instantly plotting accurate locations with rich details and even images. No clunky APIs, no databases, just Blazor, Azure OpenAI, and a sprinkle of Syncfusion magic. So that's exactly what we will build today. A complete working example you will walk away with. No fluff, just actionable code you can deploy tomorrow. So to make this session even better, let's do a quick poll right now. What's your top use case for AI in apps? And the options are data analysis or automation, user personalization, content generation, or if others, just specify in the chat. Take a second to pick your answer. Thank you all for taking your time to vote. Before we dive in, let's quickly cover what we will cover today. So here's a roadmap for the next 30 minutes, straightforward and demo focused. First, we will cover prerequisites, what you will need to follow along or try this at home. Then the heart of the session, a live demo where I will build this from a blank Blazor project to a fully interactive AI map. So we will install packages, wire up Azure OpenAI, add Syncfusion controls, and code the smart step by step. You will see real-time location generation, dynamic markers, and even conditional tooltips with images. After the demo, we will recap the key takeaways and I will share resources including the full source code. If you have any questions, fire them into the chat anytime. So with that roadmap in mind, let's dive straight into the excitement. A detailed overview of what we will build today in live demo. So now let's zoom in on the star of the show, a live demo. So I'll be coding in Visual Studio 22 with .NET 9, starting from a fresh Blazor web app template. So here's the overview. We will create an app that takes a user query like cafes in Paris and uses Azure OpenAI to generate real locations, complete with lat long addresses and 150 plus character details. Then Syncfusion's map control renders them as interactive pins, hover for tooltips, plain text for cafes, or rich with random images for hospitals. And the tech stack is simple and powerful. Blazor with .NET 9, Azure OpenAI, Chat Completions for instant location data as JSON. Then we'll be using Syncfusion Blazor components, inputs for search, maps for visualization, and spinner for loading. Why this matters? Traditional maps, they need geocoding APIs and databases. Here, AI handles the heavy lifting, accurate, contextual, and scalable. And it's all client-side friendly in Blazor. And since Syncfusion is at the core here, a fun poll for the community. Favorite Syncfusion control you've used? And the options are Maps, which is today's star, Data Grid, Charts, or you haven't tried Syncfusion yet. If you're new, this demo is your perfect entry point. So just pause for a moment to make your selection. We are grateful for your insights in our poll. Now let's check prerequisites. Before we jump into coding, a quick prerequisites check. Most of you likely have these, but if not, no sweat. I will guide you. You will need Visual Studio 22 with .NET 9 SDK and Azure OpenAI resource. Head to portal.azure.com, create a resource, deploy a model, and note your endpoint key and model name. So now let's put those prerequisites to work and jump right into the live demo. I will open a fresh Blazor project on screen and we will build this AI powered map step by step. So welcome to the main event, the live demo. As promised, we are building a Blazor app that uses Azure OpenAI to generate smart locations from queries like hospitals in New York, then renders them on an interactive Syncfusion map. No geospatial know-how needed. First, let me open Visual Studio. The project that you see on screen is a new project created by me of type Blazor web app. .NET 9 is the target framework used, render mode is server, and interactivity location is global. With respect to the changes already made to the project code, I've added a few images under the www root folder to be used as part of the demo, and the configuration details for connecting to an Azure OpenAI service and the Syncfusion license key have been added in the app settings.json file. So we will start by adding the packages we need: Newton software.json for parsing AI responses, and Syncfusion Blazor components for inputs, maps, and spinner. For that, I will head to the NuGet package manager and install the packages starting with Syncfusion Blazor maps. Followed by Syncfusion Blazor inputs, then spinner. Finally, we will install Newton software.json package. So now that the necessary packages have been installed, let me import the Syncfusion namespaces in the imports.razor file. So I'll just navigate to the specific file now. Following that, let's register the Syncfusion Blazor service in the program.cs file. So next, let's add the necessary style sheet and script resources in the app.razor file. First, the style sheets, then the script resource. So as you can see over here, we have added font awesome for icons and Syncfusion CSS and the JS resources for components. Now that the necessary configuration has been done, let's create a service that will establish a connection with Azure OpenAI to retrieve AI generated responses based on user input. For that, I will now create a new class called AI sample service under a folder named service. So I'll just proceed to add the folder and the class. So this service will take the user's query, frame a detailed prompt internally to generate the required JSON data in a specified format, and send it to the Azure OpenAI API. So once a response is received, the service will process and return the data, which can be used to dynamically update the map with relevant markers and information. So let's start with the private fields now. I will add the necessary code related to it first. So we have added an HTTP client configuration and the three settings endpoint, API key, and deployment name we will use to call Azure OpenAI. Following that, we will add the constructor. So here we inject HTTP client and I configuration and read our Azure OpenAI settings. So now let's implement the method get AI response. So the method that calls Azure OpenAI and returns the model's reply. So this is an async method that takes a user prompt and returns the AI's response as a string. So what I will do now is I will build the request body type. So we have constructed the request in chat format, a single user message with the prompt, and max tokens limits how long the response can be. So next, let's create the HTTP request type. So we post to the Azure OpenAI Chat Completions endpoint for our deployment. JSON content serializes our body as JSON. So next we'll move to the authentication type. So we add the API key header. So Azure OpenAI can authenticate the request. Here we send the request using HTTP client and wait for the response. So now let's define the success and error paths. So starting with the success path, Now let's add the else part. So if you have a look at the code, on success we read the JSON, drill into the message.content of the zero index of choices, and then return the assistance text. If the call fails, we return a formatted error string with the status code and response body. So this makes troubleshooting easier during the demo. So get AI response builds a chat request, authenticates with the API key, calls a deployed model, and returns the assistance content or a clear error message if something goes wrong. So what I will do now is I will register HTTP client and our AI sample service in dependency injection. Following this, I will also register the Syncfusion license key available in app settings.json file. So this is the code. So as the next step, we will create a model to fetch location data for map markers based on the user's input. So for that, I will add a data model called markers. So this matches the JSON fields we will get from Azure OpenAI and is what the map binds to for markers and tooltips. So let me just navigate to the specific file to add the code. So let me clean up the home.razor file. Once all the properties are added, I will just explain each one. So latitude and longitude position each marker. The JSON property attributes map JSON names like place name and city name to our C# properties. So next, I will add a few state properties. So I'll just navigate. Yeah. So I've added a spinner visibility flag to show or hide the loading spinner, the marker collection that the map binds to, and a default search query, which is hospitals in New York. So now I will just inject AI sample service that we have created to be used in one of the upcoming methods to be added. Okay. With that injected, now let's move to the most important method, get marker data. So I'll just add the necessary code related to it. So this method, what it does is that it sends a query to Azure OpenAI to generate a list of places and their details, such as latitude, longitude, address, and information about the places in JSON format. So this is the prompt that you see on screen. So once a response is received, what it does is that it passes the JSON and stores it in an observable collection object called marker collection. So following this, the Blazor maps component must be initialized to display the retrieved list of object as markers. For that, first I will code the loaded handler to be used in maps. So let me just proceed to add the respective code for that. So on initial load, the loaded handler checks if we have markers. If not, it triggers our first AI fetch using the default query. So now what I will do is I'll just drop in the code for the Syncfusion map. So let's discuss one by one. The spinner toggles based on spinner visibility. The map fires loaded to trigger our first data fetch. The zoom toolbar, it gives basic navigation. The tiles come from OpenStreetMap, as you can see over here. And markers are image pins driven by marker collection. So once AI data comes in, markers appear automatically. To allow users to interact with the maps dynamically, we will add a search box on the page using Syncfusion Blazor text box where they can type their queries. So for that, I will introduce the SF text box first. Let me just navigate to the code section. I will now add the value changed event to be used in the text box, following which I will add a method to add search icon. So this is the value changed method, the code you can see on screen. So I'll just explain this once text box is introduced in our code. I'll just move this loaded event to a different location in the file. Now let me code the method to add search icon. Following this, I will introduce the text box and a style related to it, the design. Okay. So the CSS pins the search box over the map. Then the text box, what it does is that it binds to search query. It shows a clear button and gets an icon. So we have the value change event bound to the value changed method that we have like coded. So let's just navigate to that particular section. So here, when the value changes, we update the query, clear existing markers, show the spinner, and fetch fresh results. In order to enhance the user experience, we will display additional information about each place when users hover over the map markers. So tooltips will display details of the place, including an image and description. If the search is for hospital, we will show a random hospital image above the place details. Otherwise, we will just show the details. I'll first add the necessary properties and then modify the maps component related code for the same. Okay. Now changing the maps component code. So as you can see over here, tooltip settings are set to visible. So users see a tooltip on hover or click. And inside the template, we get the bound marker as data. If the query contains a hospital, we pick a random image from hospital image list using random and render it with the place details. So as you can see in the if section, we have an image followed by the place details. Otherwise, as seen in the else condition, we just render the place details. There you go. So with that, we have completed the live coding. So let's have a look at the demo. As you can see on screen, the map loads with the default query, which is hospitals in New York. You can also see the tooltips customized with the image and the place details. So let's try a different input over here. Maybe cafes in Paris. As you can see, since the input is not related to hospitals, you just get the place details and not the images. So the app works as expected. And with that, we have reached the end of our demo. So what a ride. And look at that, we just built a fully AI smart mapping app from a blank Blazor project in under 20 minutes. How simple was that? No complex APIs, no geospatial databases, no endless setup. Just a handful of lines for Azure OpenAI calls, Syncfusion controls for the UI, and boom, natural language queries turning into interactive maps with markers, tooltips, and even dynamic images. So let's have a quick recap of our key takeaways. Azure OpenAI turns prompts into structured JSON, no APIs or databases required. Server-side interactivity plus rich controls means fast, responsive UIs. Dependency injection for services, observable collections for binding, and error handling in AI calls. So you can extend it, swap models, add streaming responses, or integrate more Syncfusion components like data grid for lists. So ready to try it? Visit the GitHub repo, the link for which would be shared in the chat now. For more details, you can check out the Blazor Maps documentation, the links for which would also be shared. With that, we have come to the end of the session.